problem, I'm supposed to use graphs and tables to find the limit as x approaches infinity, the limit as x approaches infinity, and the limit as x approaches negative infinity for this function. So first thing I have to do is plug it into my calculator. So I'll put y equals, I'll clear that out. Numerator and the denominator, I always put the numerator in parentheses and the denominator in parentheses. So I have 3x plus 1 close parentheses, and I'm dividing that by absolute value of x. Now to get to the absolute value of x, there's two ways. You can go alpha f2, and it gives you some of the key functions, the first one being absolute value. Or you could go second 0, which is second catalog, and that gives you all the functions of the calculator in alphabetical order, and the first one happens to be absolute value. But I have the absolute value one there, so I'm going to go absolute value x, close parentheses. Nope, I got to insert my parentheses for the denominator. Sorry. Nope, right there. Second, insert parentheses. There we go. Absolute value of x plus 2, close parentheses. Okay, so I'm going to graph the function. Zoom 6. So it looks like as x approaches infinity, it looks like it's going to be about 3, but I'm not positive. I'm going to look at it a little bit more clearly by focusing in my window, my y values. So I'm going to change my y values to like -4 and +4, and I'm going to graph it. Okay, so it still looks like it's going to be about 3. And I might just change my x values a little bit to see if, -10 isn't that close to infinity, but let's just get it a little bit bigger, go to -25 and 25. And sometimes I'll then change my scale, that's the tick marks. So I'll change that to 5, and I'll graph it. So again, it doesn't look like it's going to get beyond 3. So let's take a look at -3. So let's take a look at my table. So second table set. And I'm going to start at 0, which is where there was all the action happening. And I'll make my increments of 50. That's generally where I'll start when I'm looking towards infinity or negative infinity. So I'll go second table, and I get a graph, and it's 0. So I see I have an intercept there, at a y-intercept at 0.5. And as I'm going farther and farther negative, it does look like I'm approaching 3. And as I'm going farther and farther positive, let's see, can I write on this now? Negative, I can't do that. Positive, again, both ways it looks like I'm approaching 3. So I would say that the limit as x approaches infinity is +3. And I would say as x approaches infinity, negative infinity, the answer is -3. And just so we remember, the definition of a horizontal asymptote is a line. If I have a line that approaches a constant as x approaches infinity, or as x approaches negative infinity, if I have a line that is approaching a constant, which in this case we did, 3 and -3, that means that these are horizontal asymptotes.